Wonderful seeing everybody. Welcome all to December's Tech Night. Great seeing some new faces, some old faces. For those of you who have not attended in the past, welcome to Central Maine Tech Night, the second Thursday of every month, where we bring the region's technology experts and hobbyists together to network, learn, and share. You can find us on Facebook at Central Maine Tech Night, as well as online at centralmaine.org under the Tech Night tab. I'd like to thank our sponsors this evening for making this event possible and free and open to the public every single month. Thank you to CGI for their commitment here. Thank you to Thomas College's Harold Alfond Institute for Business Innovation. Thank you to Valley Beverage for our delicious beverages this evening. Thank you to Summit Natural Gas for partnering with us on STEM-related projects. And thank you again, of course, to Bricks Co-working and Innovation Space, where you are this evening at 10 Water Street, downtown Waterville, Maine. In addition to that, I'd like to say hello to the folks that are watching at home. This Tech Night is being streamed live and can be viewed via Crossroads TV on channel 1301. Thank you so much to Chad and his team and to Crossroads TV for their continued great work. This evening, I think we have an awesome Central Maine Tech Night. We have the collective with us. You'll be seeing a slide deck as well as a really cool demo and some really neat gear. So this evening, you will be receiving a robotics showcase by the Mid-Maine Technical Center's award-winning robotics club, The Collective, by Reggie Grenier, club leader and instructor of IT Information Technology at Mid-Maine Tech Center. Technological innovation and artificial intelligence have ushered in a new era, dubbed Industry 4.0 by Forbes. The Internet of Things has turned almost any customer product into a robot, and the mass availability of robots will continue to transform our economy. Without further ado, welcome.
Thank you. Good evening. My name is Reggie. I teach at Mid-Maine Technical Center, and I teach IT, information technology, and I also teach robotics. And we also have this great extracurricular activity, First Robotics, Vex Robotics. We do Skills USA, and we also do Skills USA Urban Search and Rescue. So we do a bunch of robotic stuff, but that's not our main thing that we do at MMTC. We have 13 separate programs over there, from the trades to high tech, mass media, culinary, precision machining, all that good stuff. And this is my crew that are here with me tonight, some of them. Most of them are first year. The unique thing at Mid-Maine Technical Center is we only get students their junior and senior year. Sometimes we get a sophomore, Luke, sorry. And so I only get these kids for 2 years, where other teams get their kids for 4 years or more, and they get to train them up, and the older kids teach the younger kids, because there's a lot to it, as you will see. So without further ado, we'll go through some of these slides. This slide right here, we actually won an event in 2017 right here in Maine at Pine Tree, competed against 40 other teams throughout the New England states, and we actually qualified for districts that year. And let's see, little tricky thing here. Whoa. And no sound. Is there no sound? Bummer. Yeah, I was hoping we'd get some sound, because some of these videos are going to need some sound. Otherwise, I'm going to be dead in the water. Okay, so I know the writing is hard to see, and also it is not 2108. We haven't gotten there yet. But I guess that typo didn't clear out.
We're working in the future.
Yes, we are working in the future. We are the future, right here. So this slide here actually shows at a off-season event where the kids are actually training to compete. And this This is a few slides of kids competing in other season events. This slide in the middle, we are actually in Louisville, Kentucky, competing for the VEX World Championship. We won the state championship that year. And some of the things we do here, we have our first robotics team. So you can read this right off FIRST website. If you go to type FRC, do a search on FIRST, you'll find them. You'll find their mission, what they do. It's actually started by Dean Kamen out of New Hampshire, an engineer. Created the Segway. I don't know if anyone's ever seen that. But he's done a lot for the world. There's a lot of teams throughout the world. But the main thing on this slide is FIRST actually is an acronym that stands for, I was hoping if we get the sound on the next slide, that it stands for inspiration and research for science and technology. Okay, we're going to try to get some sound. The next slide has sound, so. But basically, we call FIRST it's the sport for the mind. But the kids say it's one of the hardest things they've ever done because they have to think on their feet. They have to think outside the box. Things happen quickly. And we got things going on. Built in, right. Nothing like a live show glitch. And there we go. Okay. All right, so we'll just kind of go back.
FIRST, the final.
And the neat part about that first part, the very first 15 seconds of every match is autonomous, which means the robot is only run by the code that the kids put on it and through the sensors that we put on the robots. And we'll go back through this real quickly again, or maybe not. My curtain's pretty slow. So, FIRST is a great thing. Check it out on their website. This was made by my kids a couple years ago, and they explain it way better than I do.
The final frontier. These are the endeavors of the robotics team, the collective. FIRST, the final frontier. These are the endeavors of the robotics team, the collective. Its continuing mission to engineer strange new robots, to seek out new technologies and new opportunities, to boldly go where no team has gone before.
For inspiration and recognition of science and technology, FIRST Robotics Competition is a program for students to gather and construct a robot capable of competing in different games every year. Our team has 20 students that come together from 4 area schools, all bringing different abilities and interests.
We started with 12 students and doubled within the course of one season, each one contributing to the collective in different ways.
Are they going to hear this online?
Students that attend the Technical Center have the opportunity to apply the skills that they have been learning in class, such as
precision machining to help with fabrication and assembly, information technology to provide all aspects of design and engineering, mass media to help with video production and advertisement, and digital graphics to help with logo designs and posters.
with every challenge that we've faced, we've come together as a team to overcome it. But when we weren't sure of how to do something on our own, we reached out for support.
We have former team alumni returning to help mentor the team and teach the skills that they have learned to help the current members of our team.
They've taught us valuable building and research skills, as well as new ways to interact with the community.
Within our 2 years as a team, our interactions with the community have grown exponentially. We've taken part in programs such as the ABC Craft Fair, where we had the opportunity to show our robot to hundreds of students in the region, local politicians, and leaders in state construction projects.
We've also volunteered at both VEX and LEGO League competitions as judges. This allowed us to branch out and connect with other parts of FIRST beyond the FIRST Robotics competition.
FIRST has given us the opportunity to explore the world of potential that STEM has to offer. Although our team is still young, we are learning more every day and love everything about it.
Great, so I really can't say it better than the kid said it right there. So, if you could hear it. So they actually created that video, and part of the contest is you can create a video to show what you do in the community, what you do for robotics, and that kind of thing. It's called the Chairman's Award. It's a 3-minute video, and that's what they came up with, and I thought they did a really great job on it. The other robotics contest we compete in is VEX, and that's the smaller platform robot. But everything on this smaller platform robot transfers directly to the big robot. And the gentleman that built this, the student built this last year, came up with this concept on his own. The contest was to be able to pick up these things, they call them mobile goals, and they weigh about 5 pounds. And then stack these cones on it, and then they had to drive it across the field and actually drive it over like a 2-inch pipe and park the cones on that side to get points. And this robot could do it autonomously, very quickly, very fast. And the very first match we had with this, the kid scored 0 points. The robot didn't move. By the end of the day, he won the driver skills competition. So he got to work on it throughout the day, and he figured out his issue, and he won. And then we went on and competed again with it, and he won a tournament. It was actually 2 kids. Then we went to the state championship, and we made it to the semifinals, where our strategy didn't work out for us. But they learn a lot by trial and error. There's you know, on this machine itself, it's probably $2,000. So none of this stuff is cheap. We build these in class. These are the smaller VEX robots. And Zach, one of our programmer for the big robot, built in a gyro on here with encounters, and it can actually do a pretty good square. He's got to figure out some of the drift stuff, but he's getting it, and it's pretty cool to see these kids come up with this code to do that kind of stuff. So VEX is a standard platform. Again, you can find it online. Just go to VEX EDR. You can find all this stuff. Again, it's one of the biggest robotic competitions in the world. And the World Championship, there's like over 1,000 teams competing under one roof. And it's pretty wild to see. And we got to go to it once. Hopefully we'll get back there again. But all this stuff, you know, this is what the field looked like. And these are some of our accomplishments that we have made. You know, we've only been in business with robotics since 2014, which is relatively a young team. And we've won all these awards. Quite proud of the kids for a lot of the stuff they do. They put a lot of hard hours in. This is pretty much a year-round thing. It's not just like a football season. Kids have to train, they have to learn. A lot of kids have never used tools before. They never cut anything. The machine shop helps us out. We have a $100,000 CNC machine we got last year that we're hoping to put to use this year on the robot. So it's a lot of great things happening. Like I said, our community outreach, we go to the elementary schools and we bring the big robots, and you know, if we've won medals, a lot of time our team is fairly small, like 10 kids, and they give you like 50 medals. So we hand them out to the younger kids and they love it. They're the kids that are doing the Lego robotics, which they just competed this past weekend, I think. And Waterville's team did really well, which is cool. And they love driving the robots. And then we also do this thing at the Civic Center every year in the fall. It got snowed out this year. It's called the ABC Craft Fair. It's put on by Chimbro. So all the crafts people are there, and they invite us to set up a booth, and all the high school kids come and we demo our robots for them, let them drive them, that kind of thing. So what's happening here, this is autonomous code for this small robot. This is one that didn't work so well. Wow, that's quick. Because it was supposed to go in the corner, and this is one they figured it out. Oh, real smooth. So theoretically what it should have done is put it over that pole, and eventually he did get it there, but it seemed every time I filmed it, it didn't make it, so I stopped filming. But we have our own arena in my classroom that the kids can practice with. The school's very supportive. We have 4 separate schools coming. We have Waterville, Winslow, and this video is, while it's playing, I'll keep talking. They do a reveal video for the robot. The kids love doing that when they get their robot built. They want to show it off. This was 2 years ago, and it was called Stronghold. And the premise of this robot, which I believe is this frame, was to shoot these big Nerf balls into a goal. It was like storming the castle, and you'll see they had to go over these objects to get there. And this robot did very well. That mechanism was very heavy and it kept breaking gearboxes, but they got good at fixing gearboxes. Yeah, they had to go over this kind of stuff. Under. That bar there was 6 inches tall. I had to go over that. And the video is a little, I don't know why. And you didn't see that, but it kind of went over and tipped over. But again, that was all stuff they had to learn. We have to build all this stuff too for them to practice on. So it is a tremendous amount of work. And materials and that kind of thing. So what we do is the school supports us for the most part. Our budget is close to $20,000. So we're always looking for people to sponsor us. We have sheets up here if you'd like to take one. We have our budget so you can see. They also have Always on the Robots has a lot of Lexan on it, so if people sponsor, you know, we can put your sticker or whatever on the robot. At the very first year, NASA pretty much sponsors everybody, and so we had them for a sponsorship. We've had Caps's Pizza, Central Maine Motors. All our robots are named after Star Trek things. The Collective, I don't know if anybody caught on to that, the Borg, because we have 4 schools coming together, act as one. And I'm a Star Trek buff, so this robot was called the Genesis device. Last year's robot, I think we called it Scotty or something like that. But we're always looking not only for money, but we need help with mentoring. I have myself and Miss Brooke, Mr. Campbell comes over and helps us out. But I am not an expert at this stuff. I am not an engineer. I just know a lot of things. So it's been 5 years now. I've learned a lot, so I can help the kids quite a bit. And again, we do have the machine shop, but we need engineers, we need programmer mentors, we need all that kind of stuff to help the kids out. Like I said, they're pretty much all brand new. Zach 2.0 here, because I have two Zachs. He's our programmer. Then we have Gage, driver, Thomas, driver, Luke, Kramer, Scout, which is important to, you got to watch all these other robots, see what they're doing, see how, because you work as a team with two other robots. So it's very important to have a Scout. And we have Zach, builder, driver, human player, funny guy. He wants new shoes. Yes, he wants to design a team. He has designed a team sneaker, but yeah, we're gonna stand in front of Martin's or something. I don't know. But anyway, so I think, does anyone have any questions? Someone's gonna have a question.
How long does it take you to, say, build one of these model robots?
These ones right here? Oh, the great thing about VEX is the contest comes out in April and the kids can work on them all the time, year round. So that's what I like about VEX. First, you only have 6 weeks, and that's ending this year. Next year, I think they're gonna give you more time to build the robot. Because with VEX, it's fair because you have to use VEX components, all that stuff. With FIRST, you can only spend $4,000 on the robot only, right? That's a lot of money, okay? Nothing's cheap about these robots. But there's teams out there that work out of the NASA hangar in Houston, and they build these incredible machines that we can't build. We don't have the technology that they have. They're doing amazing things with like vision tracking and all kinds of stuff. It's great. So next year, I'm thinking, because we have more time next year, that their level will go up, but so on our level because we have more time to do it. What happens is they build 2 robots at the same time because they have that much money. We build 1 robot, we have to bag it by midnight at the end of the 6 weeks, put our serial tag on it and take a picture, and we can't touch it until competition day. They build 2 robots, they bag 1, they keep working on the second one, get all the code, which is huge, okay, for you guys know code. Building is great, but you gotta have time to put the code on, as Mr. Campbell keeps telling me. I don't give them enough time to help the kids out. But hopefully this year we're going to keep this drive base together, which pretty much has everything on it that a normal robot would have on it, only it's all stuffed down in there. And because it has, on this robot, it has a drivetrain, and it has, you want to talk about it, Tom? No, I didn't think so. He did a minute ago.
I'll help you out.
Okay, he'll help me out. So it has a drivetrain that has 2 gearboxes in it that are shifting gearboxes, okay, and it shifts by pneumatic. So it has a speed of like, I don't know, 10 feet per second or 10 feet per second, yeah, to 18 feet per second, which is in a 54-foot arena, it goes from here to there really quick, but they can't control it that fast. It's going to crash into things. So that's why they put these bumpers on them. So a lot of people are like, well, is it like BattleBots? No, it's not like BattleBots. Those machines cost hundreds of thousands of dollars. The most we can spend is $4,000, and we're at school, so we're not going to wreck it. This is all we got. So, but the machines do bang into each other and they do push each other around. So it has a gearbox in it, and it's a pretty aggressive gearbox, and it's controlled by these motors called Sims. They're actually a brush motor. Came out with a new one this year. It's a brushless motor, so something else I gotta buy. But these things weigh about 2 pounds a piece, and they put out quite a bit of power. It takes a 12-volt battery, like a motorcycle battery, and so we have to charge those every match. It has this thing here called a Robo-Rio, which is made by National Instruments, and this is the computer. It's like a programmable logic controller. It has a PWM control, pulse width modulation, it has digital inputs, it has relays, it has analog, USB, you can hook a serial CAN circuit up to it. So it's a pretty neat device, but $500. Just to give you an idea. The motors are controlled by these things called motor controllers. Okay, and there's several different kinds of them. This is a Spark, it's relatively cheap. The great thing about this motor controller is I can hook a limit switch up to it, and it has the code in it, so the kids don't need the code. So if I need something to go up, it hits the limit switch, it stops. It goes back down, hits another limit switch, it stops. No code involved, easy peasy.
However, we do have a couple moments where new people will like to play with limit switches because they don't know what they are, and then we'll get them in the middle of the match, and all of a sudden part of our robot is almost off.
Yes, dead.
Yeah.
Yep.
So we have to go by and we have to tell them, don't touch that, that's a limit switch. If you touch that, you're going to break over. So,
Yeah. We had to go with these industrial limit switches, and we find these on Amazon. They're not too expensive. But it's remote controlled by a radio. This is a wireless bridge. That's the only one they allow in first. A lot of this stuff, you pay the upfront, the fee to get in is $5,000, and that gets you into events. Unfortunately, Maine only has one, so we have to travel to one out of state, usually in New Hampshire or Massachusetts. We usually go to Reading, Mass, because that's the closest one for us. But
for folks that may not be familiar, what does kind of competition day look like? The amount of teams? What's a day look like?
We'll pack up early. We'll put all of our stuff in the trailer and we'll head out to either, like I said, there's one in Maine, Pine Tree, and then you have one in New Hampshire and Reading.
I'll come closer so people at home can hear you.
So we'll head out early in the morning, which kills us by the time we get there, as it does with everyone, because who likes waking up early? And we'll get there, we'll unpack and bring all of our stuff to our station that's designated to us. And usually when we get there, people are still coming in, and you'll usually see around 30 to 40 other teams in these competitions. A lot of other people come to win, so it's really impressive to walk around, see all the different robots. That's usually, that's what I like to do when we first get there. And with the first couple of matches, you kind of go in blind, so it's difficult to know what's there. Usually we can gauge the quality of the robot by the team. Most of the time. We had a couple this year that really impressed us with how they performed. We didn't really expect them to perform well in the level that they did. You have a first set of like round robin-ish sort of matches, which people compete to get ranking points, which put you in the elimination rounds. And in the elimination rounds, different teams who make it in the top 8 in the brackets will choose 2 other teams from the rest. And then they'll go through their elimination rounds. And those are a best of
3.
Best of 3.
Yep.
This year, we placed what was it? It was.
We were finalists. We were second.
We were.
Yep. At Pine Tree, we were second place.
Tree.
Yep.
I was talking about
Off season.
The off season.
Yeah.
So at Pine Tree we placed second, but we have an off-season event which Zach and Kramer went to, Kramer's first competition, and we placed fourth or third in that?
Third or fourth.
Third or
Yeah.
fourth, we can't really tell. But they doubted my scouting skills.
You did well.
I did well choosing teams.
It's very important, the scouting aspect of it, because you compete with 2 other robots. So you want to get the best robots that you can to help you out. In this case, we were the team captain of the alliance, is what they call it. So we got to choose the other 2 robots, kind of like they stand in a line like kickball, and you use your scouting notes and who's been picked, what's left over, and then we choose. And Tom went rogue on us and chose a couple teams, and he did really well because they were good teams.
Yeah. It's during the competitions and during the matches, it can get very hectic, especially if we do break things. There are a couple of robots that I saw at the competition, the last one that we were at, the off-season one, that were kind of like small boxes, and they would be assigned the job of cornering other robots and kind of just like tucking them into a space to make sure they couldn't do anything. That pretty much is why we got knocked out of.
No, we got knocked out because someone rammed into us at full speed.
And no, we had 2. It was like a pincer. It was like wham.
Okay, I'll take it. Good job. So, yeah, the events are usually 3 days. First day you get there, you unload, just like Tom said. They inspect your robot. It's like a NASCAR thing. They go through with a fine-tooth comb. There's 2 pages worth of rules. There's probably a whole page just on these stupid bumpers that they got to be a certain width. They can only be so far from the robot. They have to be made of this material. Your number has to be just so, whatever. And then they inspect the pneumatic system, which is the air system. Now, these little robots, there's an air compressor on here, and you'll hear it in a minute. It's quite loud. It pumps the tank up to 120 psi. Okay, but most we can use for working is 60 psi. So we put storage tanks based on how much we feel we're going to use pneumatic pistons, whatever, to complete a task. And then there's other things like gearboxes, littler gearboxes, like this gearbox right here with this little motor on it, and this little gearbox can pick up a robot that weighs 150 pounds in less than 2 seconds. Okay, this is what we call a planetary gearbox. It has 2 sets of rings in it, 10 to 1, 10 times 10, 100. So kids get to learn all that kind of neat stuff. And chains, I hate chains. Chains break. But so we first night we load in, we run some test matches, make sure the robot's going. Next day the matches start. We play 12 matches over 2 days. Okay, qualifying matches. Sometimes a match will be, they last 2 minutes and 30 seconds or 15 seconds, something like that. And you'll go compete, you'll come off the field, you might have to change your bumpers to blue because they're red or blue, you're on the red or blue side. And you might have to go right back out there 2 more matches. And if your robot's broke, you gotta fix it while you're in line. So not only do you have to build this robot, you have to think about stuff is gonna break on this robot. How am I gonna fix it and how am I gonna fix it quickly? So it's kind of cool with the stuff we come up with. The first year we found that welding is not a good thing because you can't fix a weld, okay? However, if something's screwed together and a screw comes loose, you can just put a new screw in or a rivet or something like that. So we go through the 12 matches, like Tom said, and then based on your points, how many points you've earned, win, loss, whatever. If you're in the top 8, then that's when the scouting comes in real handy. And the scout tells us, you know, this robot will work good with us because of this robot will work good with us because of that. And hopefully they're available by the time it's your pick. And you choose them, they're all happy. And then we go in the qualifying rounds, and hopefully we go really far. This year we usually get picked, which is huge because there's 40 teams and only 24 get to go on and compete. So, and that's 40 teams from Maine, New Hampshire, Vermont, Connecticut, who else we got? Rhode Island. So mostly all New England states. And like I said, we're competing against schools like out of Boston that teams work with MIT. Okay, so they have MIT kids helping them. Some teams up north have UMO helping them. So, you know, it helps, and it helps if you have engineers and stuff like that that can say, you know, this is why it's not working, and teach the students how to get it to work better, or how to build something so you can fix it quickly. Like if one of those gearboxes goes bad, that's like a half-hour fix to get that out and get a new one in. And those gearboxes cost around $500 or $600 a piece. So, again, nothing cheap. So we try to take care of the equipment best we can. So based on the qualifying matches, if you move on, and hopefully you get to win. But not only do they have win, second place, they also have all kinds of awards for like engineering. Like 2 years ago, we won an award for that we won for that. So it's really cool. And they give out like in June in New Hampshire to compete. So we haven't made it that far, but we've gotten really close. And hopefully this year with these guys, I got some more guys that couldn't make it tonight, we'll get there. Any other questions?
These are all purpose-built robots, is that correct? They give you a spec and then you're building the spec, or you're a base and then build on regardless of what the competition?
There's a concept. The one you guys want to say?
Well, every year we're given a new game to design the robots around. So every robot, like you said, has a specific task to fulfill. Last year we were able to fulfill both of them, well, all three of the tasks that you could potentially fill in for, which not a lot of teams did, but we were able to do it, which gave us definitely an advantage.
But there are size, I think what you're asking, there are size constraints. Okay, like it can only be like 120 inches outside dimension. It's up to you how you get to that dimension. And it includes the nut heads that are hanging out. So you got to take all that into consideration. It can only weigh 120 pounds. I say only, that's a lot, but once you start adding all this stuff on, it you know, our robot stood 55 inches tall and it weighed 119.8. Yeah, so we put it very lightly on the scale. And the way you lose weight on a robot is you drill a bunch of holes. Yeah, Swiss cheese in it is what we call it. And it performed very well. We had some wiring issues with it, but again, you know, it's going to happen. And the kids learn from it. But yeah, so it could only be 55 inches tall. Ours was 55 inches tall. So we pushed the limits on everything that we can. But it had to reach up, what was it, 8 feet, 7 feet. and grab a bar and pull itself up at the end of the match, and you got extra points for that. And we could grab the bar, and then we would wait for 5 seconds, and at 5 seconds we'd start going up, and it only take us 2 seconds to go up. Because our robot, you only had to be like 12 inches off the floor, the whole robot, and when the buzzer sound, as long as it was 12 inches off the floor, you got the points. When the buzzer sound, our robot went bam, and we always had some robot park right underneath of us, and it happens. Strange things happen in these events. I mean, you got the students pretty much run everything, so, and sometimes the drive coach gives bad info, which was me this year. Hopefully not. What else do we got? Yes.
So they're remote controlled, they're fully programmed.
Good question. The first 15 seconds of the contest is totally autonomous. That means whatever you program the robot to do. In this case, this year, the robot, it was like a teeter-totter. When it was static, it was all one color. As soon as the match started, it did this thing and it changed to a solid red or blue. So your robot had to be able to tell, is it red or is it blue? Because if it's not, you don't want to dump what was this year, those yellow cubes you saw, into the bin, you would lose point. So you had to program it. The field sent the code that if it, you know, which side was red, which side is blue. So we had something called a 50-50. We would line up on a side, and if the code came to our robot and said it was red and we were on the red side, it would go forward, turn, dump the cube into the box, which is pretty cool. Some of the robots, the more advanced robots, could park in the middle, and it didn't matter if it was red or blue, they could go either way. And some of them could drive around everything and go to the tall one and put a cube on. And in the World Championship, I saw a robot autonomously in 15 seconds grab 3 cubes and put it on the tall thing. That's amazing. Yeah, that's the kind of stuff kids can do. It's pretty cool.
So for the programming, what are you using for an interface or framework that would be built in for the...
Okay, so this year we used Eclipse, and we use a Java platform. Okay, so ours is programmed with Java. You can use C++. Those are the main 2 platforms. This year they're changing Eclipse and going to Microsoft Visual Studio Code. And it seems a little more user-friendly, right? He's our programmer. So, yeah. And it seemed no one in the state of Maine knew this until I brought it up, that I got on their website, and so they're changing this. We better get on top of it so we know when the season comes what we have to do. And we did. And because we meet, all the coaches meet online or in person, and we discuss this kind of stuff, what's going on. So we do have a team at Meso, not us, but there is a team at Meso, 2468. The numbers, the lower the number, the longer they've been in the competition. Ours is 4906. So that's something First assigns us. We don't pick it. And that's what they chose. And there's a team at Lawrence, just started a couple years ago. They're 6172. And we try to, work together as best we can. But I have kids from Lawrence, I have kids from Meso, I have kids from Winslow, and I have kids from Waterville on my team. So the deal I've made with them is if they wouldn't be on their team, then if they wanted to be on a team, I'd rather have them than have them sitting at home doing this. Why not do this with the robot? And they've also learned that doing this with the robot is not the same as doing this on a computer. It's a lot harder to drive. It's not the easiest thing in the world, which Gage will demonstrate here in a minute. And he's brand new at it, so watch your feet. It has a video camera on it, so it does. My computer wakes up here. Wake up. It'll wake up. I have faith in it. So, yeah, it's looking right that way, so you two are on camera. So actually we got that set at 640 by 480, and we use that because sometimes on the field you can't see what you're doing, and the only way you can see is through the camera. So they have to not only look at where the robot is at, they have to sometimes, oh, there's a cube and I need to move it and put it in here. So you have to do that with the video. When they were shooting the round ball, the kids came up with this ingenious thing to line it up, because we didn't have like a laser pointer or anything. So it had to raise up at a certain angle. The kid drew a line on the screen. He put a piece of clear stuff on it, drew a line, and when a certain point on the shooter got to the line, he shot it and went in every time. So, you know, pretty ingenious, some of the stuff they come up with. Any other questions? Ready for some demo time? All right. So, this is gonna be loud because it's out of air, but it only runs for a couple seconds. And I'm gonna go ahead and enable it, and it died. Thank you very much, robot.
Nice.
Murphy's Law. So, usually when that happens, I just have to start it back up again. It's all Mr. Campbell's fault. There we go. So it's pumping up to 120 PSI right now in this tank, which is very hard. Yeah, and the compressor is no bigger than this. So, and the compressor we have on here is a newer one. I like it because it pumps up a lot quicker. It's live, it's ready to go. You're on. You're on live TV. So drive it over that way, around so they can get a picture of it with the, yeah, don't hit the camera. You need to move up. You pulled too hard.
I didn't mean to.
I got more hardware in my right foot than
All right, you're back in business.
So it drives with tank drive, so I have to use both the sticks to move it either both forward or both backwards, or if I move different ways to spin.
So go back there and put it in high gear and do a spin.
High gear?
Yeah, go way in the middle though. There you go, that's good.
X is high gear?
X is high gear. Okay. So, all right. Yeah. So go back to low gear before you kill somebody. You already unhooked something. I see something dragging. So you can see it's on camera. So you got me on camera, I got you.
Do you want to bring it back or?
Yeah, bring it back. Don't kill anybody. Don't kill anybody.
I'll try not to.
What are we dragging? Oh, that's this stupid light thing, isn't it? Yeah. All right. Cool. Good job. All right, go ahead and disable it. No. Shut the robot off. Remember how to do that?
No.
Push the red button. Back here.
All you needed to do is put a mop on the front of it, mop the floor for your
Yeah. And then this one here was the one the gentleman built last year. He wanted to come, but he couldn't make it. And I'll do my best impression on How do you turn this thing on? There it is. None of you guys know how to drive this one?
No, I've never told me how. It's his code. It's weird.
So it has, yeah, it's connected. Okay, so he has this one in arcade drive. And then it does something. Oh, that does that. What does that do? I have no idea. I'm totally in the blind here. All right. Oh. Which one makes it go up? There we go. All right. So this was designed to deliver these cones and then drop them, but it could also go and pick them up. Sorry, Hunter, I'm very bad at this. Yeah. Yeah, so this one was pretty cool. Do what?
Give him a demo of how it picks up the cues.
Really, you want me to embarrass myself? You know I'm grading you, right? I can't drive this thing. There it goes. Whoop. Remind me to fail Hunter tomorrow. What? Yeah. If you're watching Hunter, I have no idea.
Really?
Okay, I have to open the thing, I have to do that, and I missed. There we go.
Human assist. Human assist.
Yay. Yes. So Hunter's robot, not only did he compete in VEX, he also competed in Skills USA, and he won the gold medal for the state building this kind of design with much less equipment, and he went on to compete at nationals and placed 19 out of 31 throughout the country. And this robot, I don't have to do anything to, I hope. Because this robot was programmed by Zach, and we've been working on these in class, so they have all the little sensors on it, like limit switches, a bumper switch, so if it hits something, it does something, I don't know. And then it has a potentiometer, so you don't want your arm to go all the way back because the robot will tip over. So that measures a number and they put it in. And then Zach is a little more advanced with the code stuff. So I gave him a gyro. I said, okay, so let's see what you can do with the gyro. So a gyro is angles, right? And he did this today, so it needs a little bit of work, and it's the fastest machine ever, but it does kind of a square. Wait on it. But the robot is doing this on its own, just with code. Yeah.
Actually drives better here.
Yeah. I think it depends on the floor. Whoops, that one went a little, but.
No, so you've done that to a grid of where things are.
Right.
Square them off and,
right.
And the programming does.
This has encoders on it.
Yep.
So if you had the whole layout of the field, which we do.
Got it. You're coding towards that.
Right.
To make that function and do what it needs to do.
Right. And when you use encoders, the great thing about encoders is they count and it doesn't depend on batteries. So if you do it on time and your battery gets weaker, it doesn't always work the same. So encoders count, which is the way to go. Yay! Yes, and the whole arm raise thing at the end and the claw opening.
So what do you use 120 psi for? Is it a hydraulic attachment that then goes over that? 'Cause 120 you can launch a rocket with that.
Yes, you can, but you can only store 120. The most you can use is 60.
Okay.
So the working pressure is 60 psi.
And that would be for an attachment or armature on top?
Yeah, we put pneumatic pistons. We use double acting solenoids on a lot of stuff. So, like grabbing something, 60 psi grabbing something is huge. Like the last off-season event, one of the cubes, sometimes they do dumb things at these events, and they weighted the cube that was twice the amount that a normal cube would weigh, but we could grab it so hard and our lifting system was so good, we could actually lift it up and put it on the high teeter-totter, and most of the time got it in our favor just with that one cube. So pneumatics, we use pneumatics for shifting on this. I don't know what else we use pneumatics for. Mainly grabbing. It's not really enough power to lift. We have to use gearboxes for that. And usually we use change and gear combinations. So there's a lot of math involved. A lot of stuff you can find online, which is huge, especially for mentors that never done this before like I have. But it's a lot of fun. It's a lot of work. I put a tremendous amount of hours in. I'm still married. Yeah, so like this is the power distribution panel. This actually has an onboard computer chip on it. You have to update the firmware on them. And there's 40 amp circuits on here. So this thing takes quite a bit of power. In 2 minutes and 15 seconds, depending on how many motors you have on it, you definitely need a new battery for the next match. So when we travel, we have a trailer, we have toolboxes. I mean, we have, what do we have? We have roller carts for the robot. We have a jack cart so we can jack the robot up and work on it. We have swag we bring with us. We have signage we bring with us. So that's why I equate it. And you have to carry extra parts because something's gonna break. I've never been to an event where something didn't break. And it always breaks when you don't want it to. But it happens. So yeah, it's a lot of cool stuff going on with these robots. A lot of technology. And like I said, we try to get the kids going in the elementary, get them through junior high, get them up through the high school, get them into the program. It's extracurricular. Anyone can do it. No one has to have any knowledge at all. That's the beauty of it. We'll teach you. Right? No knowledge at all. But in the few months they've been doing this, they learned how to build that, build it wrong, build it right, build it wrong. But eventually they got it. So good for them. We use PoE, power over Ethernet, to power our radio on the competition robot. Because we found that hooking a separate power pack to the the radio, that can come loose. These with the clips don't come loose, so that's a lot better. So a lot of tricks you learn over the years. Any other questions?
All right, thank
job,
you
guys.
so much for the
Thanks.
collective. Reggie, the collective, thank you so much for joining us here at Tech Night. I would just remind again that the collective would certainly appreciate and welcomes any sponsorships and or any leadership opportunities in the community from programmers to engineers. Please reach out to the team. Thank you so much for joining for Tech Night this evening. I will also love to plug, as it relates, the Central Maine Programmers Group will be meeting at Bricks the third Tuesday of every month. That includes the first meeting with the Central Maine Programmers Group this coming Tuesday, the 18th at 5:30 here at Bricks at 10 Water Street in downtown Waterville, Maine. Whether you are interested in programming want to better understand what it is, or you're a developer, please feel free to stop by to network, learn, and collaborate. So with that said, thank you again, everyone. We look forward to seeing everybody next month for January's Central Maine Tech Night. Thank you.